Subject Engineering Material Science Practical number 11. Aim to study corrosive materials to identify different types of corrosion in metals. Definition of corrosion: the chemical or electrochemical reaction between material, usually a metal, and its environment that produce a deterioration of the material and its properties. Electrochemical consideration: it must be remembered that corrosion of metals, alloys, by aqueous media must necessarily produce through the electrochemical process. Hence, it is imperative to set electrochemical criteria for corrosion of metals. As indicated earlier, corrosion of metals involves oxidation of metals and alloys from their metallic state in ionic form. It is represented as the corrosion. Types of corrosion: uniform or general. Through the uniform corrosion is an idealized form of corrosion and causes less damage than the other form of corrosion. This ideal leads to uniform thinning of the structure. The attack is measured in terms of penetration. They have the unity miles per year or per year. This can be determined by any gravimetry method. Galvanic of two metal corrosion: when dissimilar metals or alloys differing in their galvanic or corrosion potential are employed, and if they are electrically sorted, they induce this type of corrosion. The corrosion rate of the alloy with lower corrosion potential will be accelerated by that of higher corrosion potential. Previous corrosion: accelerated corrosion occurs if differential reaction exists due to previous metals joining or any deposit. Interestingly, the location starving for oxygen is forced to become anodic, and the region having free access to oxygen become cathode. Pitting corrosion: alloys in presence of certain ions are prone to pitting. The rate of penetration within the pit can be as high as 1,000,000 times as compared to plug type attack the surroundings. Intergranular corrosion: this type of corrosion occurs as a result of selective attack of the grain boundaries. When either grain boundaries become highly active or phase prone to selective attack are formed. Stainless steel, which are normally resistant to intergranular attack, when subject to an heat treatment between 400 to 900 degrees Celsius, become sensitive to intergranular corrosion. Selective leaching or parting: when noble and active element from an alloy it results in selective removal of the latter. As consequence, the alloy loses its strength and fails prematurely. Zinc alloys are well known where dezincification occurs in braces is shown in similarly. We have denickelfication, siliconization, and decobaltification. Erosion corrosion: when there is a relative movement of the corrosive environment with respect to the alloy, it can lead to erosion corrosion. Pipelines and heat exchangers are subject to such a kind of failure. Thank you.